Hello again, and thank you for joining us here at the Network Tutor subscription series presented by RouteSwitch. Today we're going to be talking about the loop guard replacement and much better performing UDLD as a mechanism for detecting unidirectional links in your network. So unidirectional link detection is a mechanism, a communication mechanism that you deploy on interconnects between devices that allows for the detection of loss of one of your links. So really useful in the fiber optic world where you have two pieces of glass going between your devices, and there's very good likelihood that somebody snags one of the links or one of them just goes bad. If you were to lose light on one of those strands, UDLD would be able to pick that up. Now, this does differ from loop guard that we had in our spanning tree configurations in that it uses its own keep alive. Spanning tree for loop guard uses STP BPDUs in order to detect unidirectional links. UDLD has a much more simplistic and faster and more reliable keep alive mechanism built into the UDLD mechanism itself. UDLD can work over glass and copper, but there's more functionality, more use for it over fiber optic links, obviously, because there are phi level characteristics that allow for copper to go to a down state in the event of a loss of transmission. So it's less likely to see a UDLD event fire on a copper interface than it is on a fiber interface, but it is supported on both fiber and copper. Now, for your note and for keep in the back of your mind before you start configuring any UDLD is to understand that it is disabled by default. You can enable it globally or you can enable it on a per interface basis, but you must enable it. It is not running automatically out of the box. Also, you need to make sure that you're able to do it on both sides. So if you're looking to deploy UDLD on a device that's interconnected with a service provider device, you're going to need to coordinate with the service provider side to ensure that you have the UDLD first configured properly on both sides and with the same UDLD mode. So make sure that you have governance over both devices before you actually deploy UDLD. So what happens when UDLD does sense a loss or a unidirectional link? Well, it has two options because there's two modes that UDLD operates in. You can either block on the interface or you can completely error disable it, preventing all communication from leaving the interface at all. So let's take a closer look at that. So these two modes that we were talking about UDLD operating in are normal and aggressive mode. And again, the difference between those is how it responds to a unidirectional link should it detect one in the environment. In normal mode, it blocks the interface, which means that it will still receive information, but it will not transmit. So it's effectively taken out of communication, but it's still receiving information across the line. So if you're still receiving BPDUs, it's important to know in block state that you'll still be receiving BPDUs on one side, but not the other. You'll be transmitting. You won't be transmitting anymore in the event of a UDLD loss. Aggressive mode completely error disables the interface, so you will not receive nor transmit. And that's probably a better way to go to allow spanning tree to gracefully fail over on all links and get all devices understanding where those BPDUs should be going. We'd rather, from my perspective, it's good to see the error disable state and then be able to recover from that appropriately. So let's go to the CLI and see how to configure unidirectional link detection. All right, so UDLD in configuration here. Let's take a look. We have a switch 3 already set up for UDLD aggressive so that we can just have it on both sides here. We are on switch 1. We have a fiber optic link. Let's do a show INT status. I have to include 0/1/0/52. We are connected at a trunk, show interface trunk. Alright, so it's just the VLANs we have built on this device going through the fiber interface that we have on gig 1/0/52. You can see we have a SFP going between the two devices. So to configure UDLD, we can do it globally with the UDLD aggressive command. Now, aggressive mode will in the event of detecting a unidirectional link, will place the interface into error disabled state, blocking both transmit and receive of frames on the interface, where regular UDLD enable will only prevent the transmission from the interface. It will still receive packets or frames on the interface. So difference between normal and aggressive mode there. So you can configure it globally. This is how we have it configured over on switch 3, UDLD aggressive. If you go into the physical interface, you can also configure UDLD there with the UDLD port command. And here you can configure, just by hitting enter, it configures normal mode by adding the aggressive keyword. You configure it for error disable state in the event of UDLD. You can also disable UDLD on particular interfaces if you have in the global configuration the UDLD enable command placed. Now, we're not going to be able to show a failure here. Let's actually do G1/0/52. But we could see that there is configuration between the two devices. We are actually bidirectional currently. The reason why we can't simulate it here is because we don't go through a patch. They're direct connected, so they're back to back to each other, and we can't simulate the loss of signal somewhere in an intermediate path, or with a broken fiber, although I guess we could break a fiber, but I don't want to do that, obviously. You could also debug UDLD events. I think you can even do packets. Yeah, you can do events, packets, and registry. Events will give you found entry on same device, gig 1/048. So these are just bidirectional links talking back and forth between each other. They're speaking BFD. I'm sorry, not BFD, UDLD currently. And that's the quick and dirty of how to set up bidirectional, unidirectional link detection.